Okay, so we're going to start with, these are all questions that I've taken from past exam papers. So they all would be things that could possibly be given to you. And really what I've tried to do is find questions where it's asking things in a slightly different way. So it's not exactly how we've been talking about them, to try and make you think a little bit outside the box. So this question is saying, determine the coordinates of a point of intersection between y is equal to sine x and y is equal to 2 sine x plus 1 on the interval where x is between 0 and 360. Okay. You've got lots of different ways that you could go about a question like this. But I'm curious to hear how you think we could go about this. So any suggestions, I'm open. Any suggestions you think. So let's say you were sitting in your exam for the last couple of weeks. This question popped up in your exam. Obviously, our first emotion might be to panic, but we're going to move past panic. What could we do after that? What could we, like, what is this question even asking? Try and give me some hints or suggestions of what you think you may do if you were given this question in an exam. Panic, all right. That's okay. Panic is allowed to be our first step. We're allowed to have a small panic window. Then we have to be like, okay, I can't panic anymore. I have to do something. So what could we do in this type of situation? Where have we seen something like that before? And when we did that, what did we do? Find the intercepts, draw these on the same graph, both great suggestions, okay? Okay, so drawing them on the same graph is a very easy visual way to see what to do. If you're comfortable with drawing the graph, drawing this won't be a mission for you. Okay, so if you know how to use your calculator well, you know what you're doing when you're working on your calculator, drawing them on the same graph is fine. So let's see what that would look like. Let's try and draw ourselves a little set of axes and get an idea of what this would look like. There are other ways to do it. I will show you the other way as well. But when we're in a situation and we're panicking, we have to do the thing that our brain thinks of first. Okay, and as a collective, our brain started to think, let's draw them. And we've been doing lots of drawings in our classes together, so we should feel quite comfortable with drawing it. All right, let me just get these values in. Okay. So if you're drawing this on your side, then you would have already put these into your calculator and you'll be able to get your graphs. So I'm going to start, because this is one that we've done a lot of. I'm going to draw y is equal to sine x. So y is equal to sine x starts at 0, 0 degrees, sine of 0 is 0. Okay, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, sine of 360 is 0. So this graph here is y is equal to sine x. So everyone should be able to quickly sketch that on your side. It doesn't need to be perfect, because this question is not about the drawing. This question is about the points of intersection. So the drawing is just something we're using to help us. It doesn't need to be perfect. It doesn't need to be like, you don't even really need to use a ruler. If you're just drawing the drawing to figure out a question, it can be as messy as you like. You're using it to help yourself. Okay. Then we need to think about what y is equal to 2 sine x plus 1 would be. So first of all, that 2 sine x, that's telling me that my amplitude is going to be 2. So I'm going to go up by 2 instead of 1. And I'm also shifting my graph up by 1. So I'm going to start there. Then of sine 90, it would be 3. 180 would be 1 again. 270 would be -1. And then 360 would be 1. All right. So we got to the exam, we saw this question, we had our moment of panic, and then we thought, if we're wanting to find a point of intersection, maybe the easiest thing will be to draw it. So we drew it. And now we are looking at what we've drawn. We still haven't answered the question though. So now looking at what we've drawn, what would be the coordinates of the point of intersection of these two graphs? Okay, so just be careful, tunnel way too. When we give coordinates, always curved brackets. But yes, and don't forget your degree sign. Okay, so our point of intersection is, let's get our rainbow pen involved over here. Our point of intersection is where our graphs are at the same points. They touch at the same point. That's a point of intersection. Okay. So our coordinates of that point of intersection would be 270 degrees and -1. That's our point of intersection. Okay, so when there's a big difference in coordinates are always going to be round brackets, but the difference between square brackets and curved brackets come into when we're talking about including numbers. So for example, if I said that x had to be, let's write it like this, x had to be greater than 1, but it had to be less than or equal to 4, okay? That bracket, this bracket over here, isn't including an equal, which means that if I was writing this in interval notation, my minimum is 1, but I'm not including it because there isn't an equal sign, so it'll be a curved bracket. My maximum is 4, but because of this equal sign, I can include 4. So basically, the square bracket means I'm including the number, and the curved bracket means I'm not including the number. So whenever we write coordinates, we always write them as curved brackets, and whenever infinity is involved, we always write it as curved brackets. But otherwise, it will depend on whether or not it can equal. Okay, so this was one way to go about this. Do I have anyone else who feels like they could think about another way we could find a point of intersection without having to draw this graph? So something a little bit different.
Sia online.
Yeah, do you think you can help me? Oh, you disappeared.
Oh, Sia, where are you?
Network, yeah. Okay, Orkunisa, can you help us?
Hi, ma'am.
Hi.
I was thinking about equating the two equations.
Yes, that is a great idea. Why would I be allowed to equate them? Why could I do that?
Ooh, that's a perfect idea.
So that's exactly, that's a road I would have taken in this type of question. I would have said, well, what about when, exactly, Kaylee, what about when my equations are equal to each other? Because when we had questions where we had straight lines and parabolas, when we wanted to find that point of intersection, we made our graphs equal to each other, and we can do the exact same thing here. So we can say, well, when is sine x equal to 2 sine x plus 1? We're saying, when is this graph equal to that graph? Because when they're equal to each other, that's a point of intersection, okay? And now we just work with it like a normal equation. So I'm going to move my sine x over there. So I'm going to have 0 is equal to 2 sine x minus sine x plus 1. So 0 is equal to, if I have 2 sine x's and I'm minusing 1 sine x, I'm just going to be left with 1 sine x plus 1. And then when we worked with equations, we wanted to have our number on the other side. So we're going to have -1 is equal to sine x. And I'm just going to write it this way around because I think it'll be easier for you to see. And when we get to this point over here, all we have to do is use shift on our calculator. So you can say shift sine -1, close that bracket, because we're doing a normal equation, and it's going to tell us -90. And so we're going to say, cool, so x would be equal to -90. But what is my period in a sine graph? How often does my curve repeat itself in a sine graph? What is your period of a sine graph? How many degrees does it take? 360, okay? So I'm going to get to the same points, 360 degrees. So I then, from here, I'm allowed to add 360 degrees. And this we'll talk about way more in grade 11. But if you were wanting to create these to be the same, you would get something like this. Yeah, guys, these take practice, but I just wanted to show you both ways so that if you ever see something like this, you'll be able to work on the fly. So these questions would be higher order questions, so don't panic, but I thought it would be something nice for us to go through. Yes, you could definitely do that. You could put both equations in, see where they're equal to each other. You could also do it as a table, so you don't even have to draw it. You could just write your answers in a table and see where they're the same. So on the right of the screen, what I'm doing is instead of drawing my graph, I'm equating my two equations. So I'm saying, where are these two equations equal to each other? And then I would be able to find my degrees and go from there. This would probably be between 2 and 3 marks. They wouldn't give you too many in case people really struggled. So they wouldn't want to disadvantage people who were struggling. But it's quite a nice question. If you would like to take a screenshot, this is your time. And then we're going to go down to our next question.
Shine, guys, shine. It's your time to shine. Take a screenshot. You guys are doing really well.
Yeah, you could use factorization if there was a square involved. But in this case, we wouldn't have anything to factorize. Yeah, the video will be uploaded. It'll be there within 24 hours. Okay. Cool. So we got the 90 degrees. When we were at this point over here, we just use our calculator. So it's a trig equation situation. So we say shift sine -1, and that would give us our -90. So we kind of have to bring all of our trig information that we learned earlier in the year into a question like this. All right. Okay, next one. This one's also, I tried to go for like slightly different questions. The diagrams below show sketch graphs, not drawn to scale, of the curves defined by y is equal to 2 sine x and y is equal to 2 cos x minus 1 for the domain of 0 to 360. The curves are labeled F and G. Okay, let's just go through that one more time. The diagrams below show sketch graphs, not drawn to scale, of the curves defined by y is equal to 2 sine x and y is equal to 2 cos x minus 1 for 0 to 360 degrees. And the curves are labeled F and G. Okay. Just looking at these two graphs. Is my sine graph the one on the left, or is my sine graph the one on the right?
Drums up, guys. Let's see.
Tell me what you think. Tunnel way to, when it says not drawn to scale, it just means that like it doesn't look exactly like it potentially would look. Good. Okay. Okay, so we can already see it's on the left. Why do we know that it's my sine graph is on the left? What about that tells us that this is the sine graph on the left? How do we know? Good, because it starts at 0.
God, they on the money.
Yes. Okay. So before we've panicked, we haven't panicked because we haven't read any questions yet. We've sort of establishing what's going on. We know that that's our sine graph, and so we know that this is our cos graph. Okay, cool. That's a great place to start. Now let's go through these questions. First question, write down the equation which defines F. So we already know that F, that's our green graph, that is our sine graph. We've already established that. Okay. Write down the equation for G. We've also established that is our cos graph. So that is just answering what we already knew, and we knew that because of looking at where these graphs started.
Marks on the bag, everybody, for free.
Guys, can I just tell you, I need to just inform you about my little tea journey that I've been going on. Whenever I get to your class, my tea is always too cold to drink because I make it before the grade 9 class, and then I get really, really sad, and I get progressively more sad about my tea throughout the grade 9 lesson. So the poor grade 9s have to listen to me talk about tea like half of our lesson time. I have found a mug that I found a typo, which is like a flask, but it's got a lid, and it keeps your tea so hot. And it was too hot for like an hour. I couldn't drink it, and it was terrible, but now it's perfect. It's like the perfect tea temperature, and I still have tea for your lesson. I'm having a great moment. So if anyone needs long-lasting tea heat, I recommend these mugs from Typo. Because they're changing my life. Okay. Yeah. It's a flask. But it's a flask, but it's a mug. Oh, it's so
also
great.
tricked her. Okay, she fell into the trap, guys. Let me tell you, when we were in the grade 9 class, the tea was so hot she couldn't sip the tea.
It was so hot. It was like burning my tongue. Every time I was taking a sip, I was like, but now, now it's the perfect temperature. It's the perfect temperature. So now I'm happy. Yes, this is, I should get like commission for anyone who buys this mug. I need to go and talk to Typo. Yes, the almighty Flug. That is what its name is. Beautiful. Okay, let's refocus. Okay, so we know which is sine, we know which is cos. Awesome. 2.3, write down the amplitude of the function y equals 2 sine x. Nice, easy question. What is the amplitude of the function y is equal to 2 sine x? Don't overthink it. What is the amplitude of the function y equals 2 sine x? Good. It's this dude over here.
My people are nailing it. Well
Good.
done.
Yeah. Can I ask you while you're here, if my equation was y is equal to negative 2 sine x, and I asked you for my amplitude, what would my amplitude be?
She likes trapping you guys.
Yes, the amplitude is always positive. Tando, where to? Mwah! Yes, okay. Even if this is a negative, guys, you need to be careful. Even if that's a negative, my A value is negative 2. That's fine, but my amplitude is 2. Your amplitude is always positive, okay? So my A value is negative 2, but my amplitude would still be 2. All right, cool. Write down the period of the function y is equal to 2 sine x. What is the period of the function y is equal to 2 sine x? Good. 360. Don't forget the degree sign. We're not talking about goats. We're talking about degrees.
Yeah, and I think it occurs normal, like, you know, you just don't realize, and then you just write a number there, and then the teacher's gonna be like, nah, sorry.
They're gonna get angry.
Yeah.
Okay, cool. Write down the range of y is equal to 2 cos x minus 1. Be careful.
Range, guys, range.
Okay, Portia, you're dealing in degrees, which means you're dealing in domain. Well, let's have a look. This is talking about y is equal to 2 cos x minus 1, right? Which means we're talking about this blue graph over here. So let's try and think about what that means. Okay, when we're talking about range, where are all these 270s coming from? Okay.
A redefinition of what range is, guys.
Okay, let's try and figure out what range is. Range is talking about what are my possible y values, okay? Oh, goodness, I'm in a highlighter mode. It's not planned. Okay, when I'm talking about my range, I'm saying, what are my possible y values? What is my maximum y value? What is my minimum y value? Okay, you've got two options here. Again, if you are feeling comfortable with your calculator, you could easily chuck that into your calculator between 0 and 360, and you'll be able to see what your max is, and you'll be able to see what your min is. Okay, that's something you can definitely do. If you are wanting to do this sort of thinking about what your cos graph would look like, we could also do it that way. So let's think about if I had y is equal to 2 cos x, what that would look like. I would start at my max, which would be 2, okay? I would go down, oh goodness, okay. I'd go down to 0, I would reach my minimum at -2, and then I would, I'm just trying to keep the same space as the same, and then I would come back up to my maximum at 2, okay? So that's why I'm making my life difficult. There we go. Okay. That's what my normal cos graph would look like. I'd start at 2, my min would be -2, my max would be 2. Okay. But that's not the graph that they've asked us to draw. They've asked us to draw 2 cos x minus 1. So my minimum was -2, my maximum was 2. But because of that -1, I'm shifting this whole graph down by 1 unit, which means my maximum is now going to be 1, and my minimum is now going to be -3. Okay, so my minimum is -3, my maximum is 1. Again, you could have done this on your calculator, you will get those values. So do whichever way you feel comfortable. Okay, when I'm writing that, I'm going to say y is the element of, because it's range. I'm going to have square brackets because I'm allowed to include those numbers. I'm going to put my minimum value, then I'm going to put my maximum value, and I'm going to have another square bracket. Okay. Coolio. Write down the coordinates of each of the following points labeled on the curves above. So I'm going to kind of scroll up and down as we go through these. The first one I want to know are what are the coordinates of P? So P is on our green graph. That's P over there. What are my coordinates of P?
We can do this, guys. We can do it.
You can use your calculators, or you can think, what would this graph look like? Anako, that is great. Just be careful with your amplitude. Lunelo, always x value before y value. Good. Okay, so when we're drawing these graphs, this would be 0, this would be 90, this would be 180, that would be at 270, and this would be at 360. Okay, because we always jump in 90s when we're dealing with sine and cos. This is our maximum of y is equal to 2 sine x, which means that that maximum point there will be 2. And so it would be 90 degrees, and my y value would be 2. Cool. Next, the coordinates of Q. That one's nice and easy. What are my coordinates of Q? Yeah, not bad so far.
Yeah, I think you guys are doing incredibly well. Oh, look.
Careful, always X before Y. Good. There we
Well
go.
done, guys.
Okay,
Well
so
done.
Q would be 180 degrees and 0. Remember, keep it in those brackets because it's coordinates. This flug just keeps on, it's like the gift that keeps on, I still have tea in here. I'm shook.
And I'm like, how can you use your mug right now? Because my hands are just.
It's not cold. Okay, next I'm wanting to know what R is. Let's try and find R over all of my pictures over here. Okay, I'm looking for R, which is, let's get the right color. R is that one over there. What is R? You should feel more comfortable with R after doing your range of this graph. What would be my coordinates of R? Yes. Smashing it, guys. Yes. R is going to be 0 degrees and 1. And remember, for these, you could just do them on your calculator if you're needing help. Okay. This is 180. Okay. I love that message. Yolanda, you've become Romeo. I love it.
I'm there. Thou shalt. I'll start practicing, guys. I'll be character.
Okay. S is a sneaky one. I'm just going to warn you. S is sneaky. Okay. S is not 90 degrees. S is a sneaky sneak. If we wanted to try and figure out what S is, what do we know about S? There's something we definitely know about S. We know something about S. What do we know about S? We know that it's at 0. Okay, we know exactly, it's an intercept. We know it's where y is 0. Okay, so we know at S it's when y is equal to 0. So let's just try and work that out. Okay, we're saying that's when 0 is equal to 2 cos x minus 1. I'm going to just rewrite this so it's a little bit nicer. So 2 cos x is equal to 1. I'm just flipping things around. Okay, that means that cos x is equal to a half. And then we're back in the situation where we can use our calculator to help us. So we can say, cool, I'm going to say shift cos, and then in my brackets, I'm going to say 1 over 2. I'm going to close off that bracket, and we will see that it's telling us it is at 60 degrees. Okay. Now, when we see this question, I would have also said 45 degrees. I would have been like, yeah, it's sort of halfway between 90. It must be 45. But that's why it was put there. It was put there purely to trick you. Okay, so what we needed to recognize in this question was that my y value was 0, and then we needed to sub it in. And when cos x is equal to a half, we can say, therefore, x is equal to 60 degrees, and our y value is 0, so our coordinates of S are 60 degrees and 0. It's the x-intercept.
Was a bit sneaky, you guys.
It was a sneaky question.
Yeah.
So we can identify its intercept because it is on that x-axis line. So we got the 60 degrees by putting it into our calculator at this step over here. We said shift cos 1 over 2, and that gave us 60. So this was your sneaky question. Okay, and the last question, t, where x is equal to 270. So that's that point over there. And if we put in, if you just put into this equation 2 cos of 270, close that bracket, minus 1, you will see your answer is negative 1. Okay, so I'm just going to show you what I did there. Into my equation, I said y is equal to 2 cos of 270 minus 1. And that gave me, y is equal to negative 1. So x is 270 degrees and y is negative 1. Nice job. Okay. This type of question comes up quite often. So 2.7 in various different ways. That's also one that they love in like the matric papers. So I thought it would be something good for us to discuss. It's actually not nearly as complicated as hard as it sounds. It's saying describe the transformation, which is really just a fancy word for saying the change or the movement. So describe the transformation which maps y equals 2 cos x onto y equals 2 cos x minus 1. So it's saying, what have you done to y equals 2 cos x to get y equals 2 cos x minus 1? What have you done to the graph? That's all this question is asking. It's using a lot of fancy words to ask something really simple. Exactly, Lonela. All I have done is I have shifted down, but we have to be super specific. How much have I shifted down? Yes. Or can you say, I've shifted the graph 1 unit down. It's literally all I have to write. Beautiful. So you're going to say shifted the graph 1 unit down. Or you could say there was 1 unit down of a horizontal shift. But you see, Tanaweti, the thing is, these questions, they are simple, but they use these really nasty words and sentences which make it seem much more confusing than it is. So what I want you to do is have some confidence when you see questions like this to think it's not really a nasty question. It's just asking me, what did I do to get from there to there? So we can almost like ignore those words because they're just trying to make our lives difficult.
Yeah, they're using the word transformation and you're like, what? Transformation, I'm thinking of translation, I'm thinking of all these things, and it's not, guys.
Exactly. Have I rotated? Have I, like, what am I? It's just like,
yeah, your mind just go wild.
What do they gain from that? I keep on telling you that mathematicians are pretentious. They like to sound like fancy. It's a thing. I don't know what to tell you. Okay. We have, let's quickly do a quick brain break and then we will come back to it. And then we'll jump to that next question. Let's do our quick brain break of the night. I know it's a little bit later than normal.
I think everyone deserves it.
It's a good one tonight though, and I trust that you will be able to do it. I'm wanting to know.
Let's do this.
I think we named him Brian. Didn't we name him Brian? Brian the Brain? Am I wrong?
It was Brian. Was this?
I think it was Brian. Yeah.
I'm not sure.
Or Brainy. Oh, I don't remember now. Brian. Yeah. Brian the Brain. Okay, I'm trying to find out what this question mark is, guys. If you want to check things sort of as you're going, let me know.
I love how everybody's not freaking out. They're so relaxed.
Super calm. Super
so
calm.
calm. Oh, look at that.
It's not 71.
They're tricks, guys. Remember, she loves putting everyone to chance. Make sure you don't fall for any trap. Just check if everything is okay first.
Not 14, not 39, not 60, not 81, not 19, not 119.
Brain dead. I agree.
42, no. 270, no.
Oh,
Yes!
goodness,
Justina!
yes.
Yes!
Congratulations.
Do you feel comfortable telling us how you did it, Justina? Okay, let's try and go through this. It was 90, so for those of you who got to 90, well done. The first step was, remember an English poem that said a rainbow looks like someone giving birth. What? That is a weird poem. Weird poem. Okay, so our steps here was we could see that these were each 4. That was sort of our nice easy step, which means that that's 4. Okay, and now this is saying that I have to multiply this first and then I can add that. So what I found is the easiest is to substitute numbers in. So for example, if I made that a 6 and that a 6, that would be 6 times 4, which is 24, and 24 plus 6, which is 30, which isn't what I wanted, okay? And then I try different numbers. And what we would see is that it's 10. So 10 times 4 is 40, and 40 plus 10 is 50. So now we know that the cloud is 10. Okay, this needs to be multiplied first, and then I'm plussing a 10. So this needs to be 25, which means my rainbows are each 5. And now we need to be clever. There's not one rainbow, there are 2 rainbows here, which means it's 10. There are 2 clouds here, which means it's 8. And so it's 10 times 8, which is 80, plus 10, which is 90. Well done to everyone who got close.
Well done.
Yeah, Suzanne, I'll pop up the now. It was hectic. Yeah, next time. Okay. Oh, okay. Let me quickly pop up this so you can screenshot. I'll try and do it in stages. So if you're wanting a screenshot, that's the first part of it. And that's the second part. One day you won't fall for my tricks. One day. Okay, cool. I'm just trying to think which question I want you to do now. Yeah, let's do this one. Okay. Okay. Below is a sketch of 2 trigonometric graphs, f of x, which is equal to 3 sine x, and g of x, which is equal to 3 cos x. Now, what I recommend you do in any test or exam situation is if you have highlighters, use highlighters. If you don't have highlighters, but you have like a dark pen or a pencil, like try and distinguish what your 2 different graphs are. Anything that you have that can try and make it distinguishable. So we've got f of x, which is 3 sine x, and that is this graph here. The thing with highlights is it just makes it like really clear with what you're working with, and it seems to do something good in your brain. And then g of x is 3 cos x. Okay, and now we knew that those were them because they were labeled for us. So g and f. Okay, cool. So now we know what our graphs are. First question is, what is the period of f? So what is the period of this blue graph? Good. Okay, my blue graph is a sine graph, which means that my period is going to be 360 degrees. 360 sheep, precisely. 360 rounds of cheese.
I'm thinking of ribs. That's what I'm thinking about. 360
typo floods.
Oh yeah, for you it's the flags.
It's the flood. Okay. What is the amplitude of G? What is the amplitude of G? Good. 3 flags. Yes. Okay. That 3 is telling us what that amplitude is doing. It is 3. Good. Okay, next question. Use the graph to find two values of x, where x is between 0 and 360, where sine x is equal to cos x. Okay, so this is, I think this has been written incorrectly because they wouldn't have done graphs that aren't there. So this should be 3 cos x. Okay, so all they're asking is let's just find 2 points on this graph where they are equal to each other. So we've got a point over there, and then we've got a point over there. Oh, you know what? It probably was cos x. I'll show you why now. Okay. Okay, so at the moment, those would be my points of intersection, but those would be really yucky values. I suppose it's not so bad. We can figure those out. Okay, so let's try and figure out that coordinate over there. In order for us to figure out that coordinate, what would be my degrees? So what would be my x value that I would be putting into my equation? What's my x value at that point? 45, good, yeah. Okay, because it's between 35, 30, and 60. So we can then substitute that into our equation. So we can say, cool, well, what is my y value? And we could use either equation when x is equal to 45 degrees. Then just grab your calculators. So, sorry, it's getting really dark on my side. I'm going to say 3 times sine, and then in brackets 45, and I'm going to close off that bracket, and I get the answer 3 root 2 over 2, and we can write it exactly like that. We don't need to make it into a decimal, and so my coordinates would be 45 degrees and 3 root 2 over 2. That's that point over there. Okay, then we need our next one, which is over there. What would be my degrees there? What would be my x value there? It's okay, Beverly. Good, 225. You see, we're jumping in 15 degrees. Each time it's 15. So this over here would be 225 degrees. Okay, so I care now about what would be my value at 225 degrees. And so we're going to say, what would be 3 times sine, and then in brackets 225, close off that bracket, and we would get negative 3 root 2 over 2. So 225 degrees and negative 3 root 2 over 2. And those would be my points of intersection. Nkateko, words of wisdom from Nkateko. The universe is always listening. Okay. The next question I thought would be a good one for us to talk about, because we haven't actually spoken about stuff like this. We are going to speak about it more in consolidation week, but we haven't spoken about it at this point yet. So the graph of g of x is equal to 3 cos x. Don't worry, I'll scroll back up now for screenshots, but I want us to talk about this question. So this question is saying, give the equation of h of x. So that's just saying, provide a new equation and call it h. So my new equation is going to be called h, which is the reflection of g of x in the x-axis. Okay, so g of x is this green graph that I have here at the moment. If I reflected it in my x-axis, wherever it was positive, it would now be negative. Okay, so this point over here, which is negative 3, is going to land up being positive 3. Okay, and so my graph is going to, oh goodness, my graph is going to land up looking something like this. if I reflected it over the x-axis. And when I reflect it over the x-axis, my amplitude is still 3. I'm not shifting, but where am I starting now? Am I starting at my min or am I starting at my max? I'm starting at my min. And when I start at my min, it means that my A is negative. Okay, so all this means is we're just going to say it's the exact same graph, except it's a negative because it's just been flipped over. That's it. Not so bad. Okay, cool. We landed up getting through some nice questions today. I'm just going to zoom out a little bit so you can get this whole question in the picture. But I'm happy. Nice job, guys. I hope that trig functions seem a lot less scary now. And like not like these big foreign curvy DNA things like I did in our very first lesson. Do you remember how scared some of you were, Shay? Okay, but during the holiday, we will be here. We're going to do some cool questions in our consolidation weeks. We're going to look at the different types of questions like this that get asked in exams, and we're gonna get there. It's going to be great. I will be here with you for the next 3 weeks. Bring your hot chocolates and your flugs.
Yes, pajama party. Remember, everybody. Pajama jams. That's what we're going to be doing.
Pajama jams in maths. Maths jams. But for the moment, you can do your quiz. And I will see you guys on Tuesday.